Hello, in this video I will show you how to build from scratch laser scanner, handheld device for laser scanning, which is shown here in those images. Today we'll focus on building hardware and also compiling software that is running on the scanner itself. This repository, which is shown here, consists of software for post-processing, and it won't be covered in this video. We'll focus on this repository, Mandeye controller, that consists hardware design and links to Onshape, where you can download or tweak 3D prints, and also the C++ executable that is run on Raspberry Pi. So the video will be structured in a way in which in the first part I will show how to build it from scratch, assemble mechanically, and then I will switch to Raspberry Pi and go through compilation, setting up USB mount, and also setting up a service. So please enjoy. Okay, so we start assembly with pogo pins. Pogo pins are those compliant guys that mates with battery connection. So here it will be installed inside a 3D printed chassis, and this chassis is shown here. So it fit snugly here. And it's connected with this strip. You can use any metal strip that is easy to solder. So we cut to the size and solder. Take a wire and solder wire to those strips. With strips and wires soldered, we put heat shrings and take a M2 screw with nut and screw these two parts and the bottom together. We can use a little of hot glue to secure everything. Now we take Vago connections and we connect it to the wires that we soldered a moment ago. We need to secure those Vago connections in place with hot glue. Having those, we can assemble nuts. Those nuts will be holding the Raspberry Pi inside. Here we are testing a battery. It should be about 16 volts. And here we are soldering the LED with resistors. Resistors are to limit the current that is flowing out from Raspberry Pi to manageable amount. I recommend to use 220 ohms resistors. Be careful with that to wire it in correct direction, those LED. And here we are crimping connections that will be mating with gold pins in Raspberry Pi. And now we are soldering and crimping connections to buttons. Now it's time to install DC-DC converter that will give 5-volt power to our Raspberry Pi. Here is a converter, here is Raspberry Pi, and here is top part of the assembly. Here is a buzzer that I forgot to install in a moment ago. And here are the wires that are going to power Raspberry Pi. Please take into consideration, please note that those wires are a little thicker than typical wires that are used for wiring LEDs. It's important because we need to deliver enough power to Raspberry Pi. I decided to secure DC-DC converter with Kapton tape. It's a very good insulator. Next step is to test if DC-DC converter works and provides 5 volts, and if we have correct polarity. As you can see, everything is correct. Now it is moment to assemble a wire that will connect Livox LiDAR and Raspberry Pi. I will test if everything is wired correctly. I took my power supply with limited current. I will test here what is the maximum value of the current. I will set it at about 200 milliamps, and let's connect LiDAR. It's not enough to start LiDAR, but we can see that it's not short circuit, so it looks good. So turn it off. And apply larger current. As you can see here, the LiDAR came to life. Now assemble LiDAR with rest of the system. Those are M3 screws. Now let's secure Raspberry Pi with M2.5 screws. There are 4 of them. and take those long M3 screws and screw everything together. Now we connected the battery. The LiDAR should start, the Ethernet LEDs should blink, and a blue LED should show that unit is powered. At this moment it's time to flash our SD card. I'm using Raspbian Imager and choose a newest version of Raspbian that is called at this moment Raspbian Bookworm. I also predefined the username and its password, and also credential to connect to Wi-Fi, and also a location for Wi-Fi. Here I'm flashing, it is sped up 20 times. Next we are going to switch to Raspberry Pi and update and compile software. Okay, so we are now on our Raspberry Pi that we flashed a moment ago. We are connected to our wireless network, and we start our compilation of the project with installing updating sudo apt get update to get latest repositories. Great. With that, we can clone our software from GitHub. Okay, next we need to cd to that directory, and we need to git init submodules, git submodule init, and git submodule update. And as you can see, sub repos are cloned now. Okay, we have a readme file with all necessary input. Unfortunately, here is not rendered as markdown. So here is a list we already done, update and upgrade. Here is a list of libraries that we need to install before we compile. Okay. and we can go with our build. Proceed with our build. So we create a build folder here, and here we have our CMake configuration. Okay, so the first argument says that we want a release build. The second argument says what hardware we have. At this moment we support two hardware platforms. One is Raspberry Pi 4 and second one is Raspberry Pi 5, and also custom made carrier board for compute model. But if you are building open source version, you can go with Mandeye hardware standard or Mandeye hardware standard dash RPI 5. So let's go with that. As you can see, it's configured. And now one remark. We have here Raspberry Pi with 1 gigabyte of random access memory. That is quite small number of the available memory bytes. So I think we shouldn't go with make dash J4. I would rather go with, for to be safe, make 1. So we will build it single threaded. No, this part is sped up 20 times. Okay, so we are back, and it was built. At this moment, we have few executables, and we can run LED demo to test our outputs, the PO outputs. At this moment, you should see LED flashing on and off, and buzzer beeping. The same can be done for buttons. If you press button, you should see info in command line and also LED flashing. Okay, we are back on our Raspberry Pi. In previous chapter, we compiled and tested our LED. So at this moment, we will configure our LAN to use with LiDAR. So we are on 80H0 and we need to set our address to manual. So we add an address 1.5, as I remember correctly. Let me check in our manual. Manual was written for older versions on Raspbian that use another way to set up the network interfaces, but on this newest Raspbian you don't have this file. So we go with network manager. Okay, so 192.168 1.5 and netmask 4, and gateway we do not need to enter anything. Okay, so with that we can disconnect our LiDAR and connect it again. And yeah, there are tools to visualize our LiDAR data, but they are not available for Raspberry Pi. You can test LiDAR using Livox Viewer 2 version for Livox Meet 360, but sadly it's not available for Raspberry Pi. So if you want, you need to have a PC with x86 platform with Windows or Linux. Okay, with that set, we need to set up support for auto mount of USB drive. Hopefully that didn't change on Raspbian bookworm. So okay, set USB mount. So we go to our temp directory. We clone the USB mount, data number of the script. We cd that, the jup, and we build our package. It will take a little while. We go back and we apt install created USB mount package. Okay. We want to continue. Okay, and we go to sudo nano USB mount conf. Okay, so we have predefined mount points here in this configuration file, but we want to support VFAT, X2, X3, NTFS, and we add here NTFS as well, just to be on the safe, to have support for FS and options to be to have this pen drive routable. So we copy from documentation. Oh, it's no. I would prefer go with Vim. Get install Vim. Give you a second to install Vim. I cannot use Nano, but Nano is available by default on Raspbian distribution, so I decided to put it into documentation. If you are not happy with Vim, you can still use other tools. Nano is fine. You can even use Genie, but remember to use sudo. Okay. Let's go with Vim. Nice. And Shift E. The FS, and with FS mount options. Great. How to exit Vim? Escape. Colon VQ. We are done. Okay. Okay, we need to create a UDEF rule. Once again, here we go with Vim and add this content. And we need to restart UDEF rules. And now we can put our pen drive, and hopefully we will see it mounted as media USB, and we can see pen drive. Okay, so we are on our Pi, and now we will start an application, install the installer service. So at this moment we should have our USB working, our GPIO is working, so we can at this moment start an application. So cd Mandeye controller build, and you should hear buzzer making 3 beeps, and you should see this log. You can actually get a status of some device with call. Okay, so here is status. So we do not have a GPS, so it's okay. Here is our Livox. It was detected correctly. And it is in idle. If we want to start scanning, we can pick one of the buttons. One is for stop scan, and second one is for continuous scan. Let's start stop scan. Let's start scanning. Let's click one more time. 3 times you need to click to stop scanning. It's in stopping mode, so here it's recording the data, and it's idle. Great. And the directory should be created, but it is fun to work with like that, but we need to have it as a service. So let's stop it to start it with our Raspberry Pi. So let's go to our README, and we can have and the manual actually asks us to create a file called Mandeye-controller.service. So go. So let's copy everything here. Okay, where is this console? Okay, oh, nice. I didn't see that. Okay, so we need to adjust names of user Mandeye, exec start Mandeye. Okay, because what we are doing now is a service script, and we actually starting a service in the user mode, because we do not want to start it as with a sudo user for various reason. We need to provide a user. So here is a user Mandeye, and exec start, it is a path to our build program. Exec start pre is pre-start sequence, so we want to sleep for 20 milliseconds. So after starting a system, it will to wait about 20 seconds. It is for making sure that our system is stable. So we save it. We need to reload daemons. Okay, I will close. Yes, I will close those tabs. Okay, okay. We will enable our new service. System CTL enable Mandeye controller service. Okay. We will start the service sudo system ctl start. You should hear welcome beeps. You can also check out the status of running service, and it's running. You can also use curl or JSON to get status. Oh, I forgot to have a port. Okay. Okay, so let's test our service. So we'll start the system. Leader should start automatically after applying power. And the system should follow. Okay, the system started. And now probably those 20 seconds are counting down. Great. So our system is ready to work. I started now continue scan, and you should see a data appearing here. Okay, I think we are done with setting up this system. So thank for now.